Hello, this is Dan Alford with Arc Specialties. Today we have an episode for you that we're calling All's Weld That Ends Weld. Anybody that's done welding automation of cylindrical vessels and tanks knows that there's two ways to hold a part. You can either use turning rolls or head and tail stock. Many people prefer turning rolls because they're simple. You simply put the part on two sets of wheels permanently mounted on the ground, rotate the wheels, and the part rotates. Up at 12 o'clock, you're welding. It's a great system because it's flexible, it's simple, you don't have to lift the part, and so most customers prefer that technique, but there's some problems with it. In this case, we actually built the entire system on turning rolls, and we determined that there were enough deficiencies in the approach that we had to revert to a head and tail stock, and I wanted to share this with you today. So when you're running turning rolls, you've got a couple of problems. First, you have to have some way to control the part to prevent it from walking left and right. There's a number of ways to do that, and including just some rollers at the end, or you can do it with tracking systems. But once you overcome that, you still have two more problems. First is, with turning rolls, unless you know the exact diameter and circumference, it's very difficult to know when you welded all the way around the vessel. So if your vessel diameter isn't accurate or you have any slippage on the turning rolls, you're going to have problems. And once again, we can get through that too with using external encoders. So there's a way around that. But the thing that got us on this project was laser tracking. This one couldn't be welded without laser tracking. And the problem with laser tracking is you're actually finding the groove about 2 inches away from where the torch is. So imagine when the laser goes over the groove, it knows precisely where it is within a few thousandths. But what's really important is where will that groove be when the vessel rotates the next 2 inches underneath the torch. And a couple of things can affect the position of the vessel. For example, let's say there's some irregularities on the tank itself. If it moves up or down, we have no way of detecting that. Or if we have any slippage, we have no way of detecting that. And so we were able to overcome all these deficiencies and actually weld the tanks with turning rolls. But we decided in the end, we'd have a much more robust system if we converted over to a head and tail stock. With a head and tail stock, you have extremely precise control over the position of your tank. You have no problems with the seams bumping over the wheels at the bottom. And if you use a servo-driven 7th axis, the precision is absolutely as accurate as that of the robot. So the point of today's video is to compare and contrast turning rolls to head and tail stocks, because if you're going to weld cylindrical parts in the flat position, you're going to have to pick between one of these two technologies. I don't regret that we built this with turning rolls. We've successfully used turning rolls many times in the past, but in this case, we felt like we'd have a much better system for the customer if we'd convert over to head and tail stock. If you're going through this same decision-making process, give me a call and we can discuss it. Arc Specialties thrives on problems. Send us yours.